Well, good day. We are going to work on this particular worksheet, the properties of logarithms. It comes from this lovely packet, the meaning of logarithms. Okay, before I do some examples from this, I want you guys to review just a little bit. Let me grab this little sheet right here. Do you guys remember that when you're doing exponents, if you're multiplying exponents, let's just do several here, that as long as the base is the same, you can simply add these exponents, which here that would give me 10. Okay, so when multiplying, you can add your exponents. And you probably also remember that if I'm dividing right here, I would do the opposite and I would subtract my exponents. So this would be the same thing as x to the 8th. Okay, well also remember when you're taking the log, your answer, these are exponents. The logarithmic function is the inverse. It's the opposite of the exponential function. And it's going to make more sense of why we do what we do when we get ready to actually solve equations. But I just want to show you something that works, okay, with numbers that you can see. So that when we start doing it with variables and other numbers, you're like, oh, same rules apply. Now, you guys probably realized from last week that the log base 2 of 4 is 2. And you might be like, why? Because 2 squared is 4. So I did some here that you knew. 2 to the 3rd is 8. 2 to the 5th is 32. Okay? So I just want you to show you this little trick. You guys know this. If you don't know this, you can hit this in your calculator. Log of 32 divided by the log of 2, and it would give you 5. Okay? But 32 is the same thing as 8 times 4. Now remember, on exponents, when you are multiplying, you can add the exponents. And this answer over here is an exponent. So I could write this as log base 2 of 8 plus, because that's an exponent, log base 2 of 4. And I want you to see something. I'm multiplying, so I expanded this. I made it bigger by adding. And again, what is the log base 2 of 8? Remember, it's 3, because 2 to the 3rd is 8. And log base 2 of 4 is 2. 3 plus 2 is 5. So I got the same answer. Okay, so that's kind of cool, and it will help us later on. We're going to play this game when working with this worksheet over here. So I kind of already did this one, but notice here, if I'm multiplying, I can expand it. Notice I wrote the word log twice, and that's the same thing as log of 6. That's a big 6. Plus the log of 11. I was looking through my phone earlier and I messed up, and so I started over. Okay, you don't see the base here. So do you remember what the base is if you don't see it? It's a base 10. Okay, so you don't even need to worry about it. I think all of these on this worksheet are a base 10 just to keep it easy. All right, so look at this one. First of all, there's a little 5 right here, and I don't know if you remember this from last week, but when you have an exponent, you can bring this exponent down front. So the first thing I would probably do is write this 5 log of 6/11. That's the same thing. So bring your exponent down front. All right. And this is one way, and I'll show you another way to do it. So then I am dividing. I can expand this by doing the opposite, which would be subtracting. So I would write this, and I'm going to put this like this. Put this bracket in here. Sorry, I'm looking through my phone. The log of 6 minus, because I'm dividing, the log of 11. And then I could go ahead and distribute this in right here. So this would be 5 log 6 minus 5 log 11. And that would be your answer. So we're just practicing expanding it. Now, you could have done this all in one step. You could have written this as, remember, all of this is to the 5th power, so I could have written this as 6 to the 5th over 11 to the 5th. And then started to play my game. I could have said, okay, well, that's log of 6 to the 5th. Minus, because I'm dividing, the log, and I'm going to run into this other problem right here, 11 to the 5th. And then bring your exponent down front. So that'd be 5 log to the 6th minus, and then bring your exponent down front, 5 log to the 11. All right, so notice we get the same answer. Doesn't matter how you do it. Okay, so let's try this one. This exponent only applies to this. So it'd be log of 2 to the 4th minus, because it's dividing, log of 5. And again, these are base 10, so you don't see anything, so you don't need to write that. This exponent can come out front, so my final answer is 4 log of 2 minus the log of 5. So these shouldn't be too bad. Let's try another one. Actually, this is the same thing. This one's going to be the log of x minus, and then you're going to bring the 6 out front, 6 log of y. So I'm not going to even worry about that one. Let's try this one. This one's a little tricky. Notice, since this is the cube root, that this is the same thing as log of x times y times z to the 1/3. Okay? Everything in here is to the 1/3. So again, you could go ahead and put the 1/3 out front, or you can go ahead and give the 1/3 to everything inside. So I just kind of put it in towards everything in the inside is to the 1/3 power. Now these are being multiplied, so when I expand it, it's going to look like this. The log of x to the 1/3 plus, because when you multiply, you expand by adding, the log of y to the 1/3 plus log of z to the 1/3. Now, I don't care if you do all this at one step, but remember these exponents need to be written in front of the log. So my final answer is 1/3 log of x plus 1/3 log of y plus 1/3 log of z. And yes, you could technically write that 1/3 and then do parentheses or bracket, log of x plus the log of y plus the log of z. Personally, this one's my favorite answer. Okay? Now, ding, turn the page. What happens when we want to go the opposite way? Notice here it's telling me to condense. They have 2 logs, same base, they both have the base 10, so it wants me to condense this. So you're going to take the 2 and you're going to only write the word log once. Since you're subtracting, I know I can combine that by dividing. So I would write that as the log of 3/8. This one, see how there's a number written right in front of the word log? That means that that was originally an exponent. So I could write this as 3 to the 4th. Just take him, bring him back up. Minus log of 8 to the 4th. Notice again, I'm just bringing him back up. So I'm going to write log one time. I notice they're both to the 4th power, so I'm just going to do this all in one step, but that would be 3/8 to the 4th. You could write 3 to the 4th over 8 to the 4th, however you want to do it. Okay? This one, again, this 2 can go up here. So it's log of 12 to the 2nd power. So I'm going to write log one time, and it would be 7 over 12 to the 2nd. And you can leave it just like that. Probably should technically put him in parentheses. Let's see if there's a yuckier one. I don't know. Does this one look too yucky? Notice we have a base of 4. So you can only play the game if it's the same base. So I'm going to write the word log one time, and it's a base 4. My first value is a u. I'm subtracting, which means I know I would divide, and that's going to be v. And this guy, he's written right in front of the word logs. That means he's going to swing up here, v to the 6th. I know, craziness, right? And, ooh, see that plus sign? Same base, log base 3. I'm going to write that u to the 6th, and this is going to be times, notice that 6 is going to come up here, v to the 6th. So they're both to the 6th power, so I probably would go ahead and write this log base 3 of uv to the 6th. And that's it.